Welcome to the Cmos fabrication process. Okay, now in the Cmos fabrication process, we are having four types of fabrication process. The first one is N-well fabrication process, and the second one is P-well fabrication process. In this two well fabrication process, we are having a major drawback. That drawback we are going to call it as latch up problem. Okay, to overcome this latch up problem, we are going to move to the next fabrication process, that is twin tub fabrication process. And SOI, this is a emerging technology. Okay, SOI, which is abbreviated as silicon on insulator. Is it clear, all of you? Once again, I'm telling that to overcome the drawback present in well fabrication process. What is the drawback present in well fabrication process? Latch up is the drawback. Okay, we are moving to the next fabrication process, that is twin tub and SOI. Now we will see, when we are discussing about twin tub and SOI, why twin tub is not preferred compared to SOI. Okay, among all the fabrication process, which fabrication process is better, we will see. Is it clear? Okay, now if you observe the abbreviation of CMOS here, CMOS stands for complementary metal oxide and a semiconductor. Is it clear? That means in this single IC we have to fabricate two transistors. One transistor is NMOS transistor and another transistor is what? PMOS transistor. We have to fabricate these two transistors in a single IC. We know very well, to fabricate NMOS transistor, we required which substrate? We required P-type substrate. But to fabricate PMOS transistor, we required which substrate? Absolutely, we required N-type substrate. Is it clear? But here we have to fabricate CMOS transistor. That means in a single IC we required NMOS and we required PMOS. Then anybody are having any idea how to fabricate these two transistors in a single IC? Yeah, absolutely. We have to take two substrate. That means one on another. That means let us consider it is one substrate, you have to form another substrate. Based on this criteria, okay, based on this another substrate, the name is given as well. Okay, whatever the another substrate you have considering, if it is a n well, that means you are considering n substrate, then you are going to tell it is an n well fabrication process. If you consider it is as a p well, okay, if you consider as a p well, you are going to tell, okay, p well fabrication process. That means don't forget, one substrate is a base substrate. Now you have to consider another substrate. Is it clear, all of you? Okay, this is a very important point. And one more important point I have to talk about. Okay, if you observe that, if you want to fabricate n well, okay, n well, don't forget this well should be at this side. Okay, here, if you want to fabricate p well, okay, if you want to fabricate p well, very important point, the p well should be at this point. That means here the p well should be present. Is it clear? This is a very important point. Why? Because we are having a proper reason for that. Is it understood, all of you? What is the proper reason? I will talk about that proper reason for you. Okay, now if you observe that this is a CMOS technology. This is a CMOS technology. Now in the CMOS technology, always observe that you are having two networks. One is pull up network, another one is pull down network. Okay, the two gate terminals of this network must be tied and a common input is given. The two drain terminals must be tied and a common output is considered, and the source of one network is given to the VDD supply and the source of another network is given to the VSS supply. Here very important point, what is this pull up network? Innocence, always remember this pull up network is a PMOS transistor and this pull down network is an NMOS transistor. That is the only reason why the wells of CMOS are in a stipulated, that means sorry, in a, okay, correct places. That means if you observe that this is a substrate, you have considered n substrate, observe very carefully. Okay, here if you want to design a p well, okay, don't forget this is one more substrate. We know very well that in p well, that means in this substrate which transistor is going to be developed? Absolutely, that means NMOS transistor is going to be developed. therefore Nmass position is down position, therefore the well should be here. Okay, here the P well should be present. Okay, similarly, if you observe that if the substrate you have considered is a P substrate, if the substrate you have considered is a P substrate, okay, now if you want to design with N well, now you can clearly observe where in N well which transistor can be formed. Absolutely PMOS transistor, where the PMOS transistor is present at the top, therefore here the N well should be present. That is the only reason. Is it clear why N well is always preferred at the left position, why P well is always preferred at the right position? I hope that are you clear, all of you. Now we will see the N-well fabrication process. Okay, after that the task is given to you to perform the P-well fabrication. Now coming back to the N-well fabrication process. Okay, what is the first step in any fabrication process? Anybody from the, okay, anybody? Yeah, absolutely. What is that? Wafer creation. Now I have considered a wafer. Okay, I already said that three parameters you have to talk about: resistivity, diameter, thickness, and don't forget doping. Is it clear? Now let us tell me, if you are doing N-well fabrication process, what should be the substrate? Absolutely, the substrate must be what? P-type substrate. I hope that are you clear. Now observe very carefully. After the first step, wafer creation, what will be the second step? Absolutely. What is that? Oxidation. As usual, we have to do the oxidation. After that, we observe that there is a silicon dioxide layer. Okay, after these two steps, what will be the third step? Absolutely, photolithography and etching step. I hope that are you clear. Then you have to form a photoresist. Is it clear? And you have to take the photo mask. After that you have to expose with UV light. Is it clear? And wherever you required, here we require in two places. Why? Because one is for well, we require which well? N well. N well should be present at this position, right? Therefore we have to cover here, and we have to allow here, and we have to cover here, and similarly for here we required a gate. Okay, therefore we have to cover here. That means we have to open two windows here. At this position we have to open one window, at this position we have to open another window. Is it clear? After photolithography and etching, will you please tell me what is the acid we are going to use in etching? Absolutely, hydrofluoric acid. Is it clear? Okay, after that, after this step, okay, anybody from the class, will you please tell me how the structure will be? Absolutely. This is the structure. Is it clear? Now, if you observe that I opened two windows in my oxide. Okay. This is for what? This is for my well, N well. Okay. And this is for what? Okay. And this is to form which transistor? Absolutely, NMOS transistor. Okay. Don't forget, this is for my N well. In N well, I am going to form which transistor? PMOS transistor. I hope that are you clear. Now just observe what is happening after opening a window in an oxide. Okay, what should I have to do? First of all, I should create a well here. Is it clear? I should create a well. I should create a well. Is it clear? I should form or create a well. If you want to create a well, diffusion process you have to do. In diffusion process, first of all, you should heat the substrate to a high temperature, and you should expose the n-type impurities gas. Is it clear? Don't forget, when you are exposing n-type impurities gas onto the substrate, okay, definitely here also there is a window open, therefore here also there is a chance, okay, forming well. But here we doesn't require any well, therefore you should cover here with a mask. I hope that are you clear. You should cover with a mask. Is it clear? Therefore I'm going to perform, observe very carefully. Okay, I'm going to perform a diffusion process by heating the substrate here. Okay, by covering this with a mask, I'm going to perform a diffusion process. There I can have my substrate, one more substrate. What is the substrate name? Absolutely, what is the substrate name? I can tell this one is as what? N well. Is it understood, all of you? Okay, this is a very important thing you have to talk about. Is it clear? That means after covering with a photo mask, if you expose with n-type impurities here, here also the n-type impurity will be there, but it won't fall into the substrate. Why? Because it is masked. Is it clear? Then your well is ready. Is it understood? Okay. Okay, now observe well is ready for you. Then what is the next step? That means here after wafer creation, after oxidation, after photolithography and etching. Okay, after photolithography and etching, what is the extra step you are having? Absolutely. What is that? Well creation. Well creation. That is an extra step. Okay, in this CMOS fabrication process. And remaining, what is the next step? From there onwards, anybody from the class? Absolutely. What is the next step? Gate oxide. Okay, or growing a thin oxide. After growing a thin oxide, you should perform photolithography. That means after growing a thin oxide, you should perform photolithography and etching, where the thin oxide should be available at this position and at this position. Why? Because don't forget, you required two MOS transistors in a single substrate. I hope that are you clear. And observe that after growing a thin oxide, after photolithography and etching, we required a thin oxide at this position and at this position. Is it clear? Then after that, what is the next step? Absolutely, chemical vapor deposition is the next step. For chemical vapor deposition, okay, polysilicon we are going to consider. Here a chemical vapor is going to be present like this. Okay, it should be present only at these positions, right? Okay, therefore once again we have to do photolithography and etching process. After that, how it will looks like? After that it will be looks like this. Sorry for that. Okay, after that it will be looks like. Is it clear? Then after that, what should be the next step? Absolutely, diffusion is the next step. Don't forget, in the diffusion, what is the important step we have to talk about? Absolutely, heating the substrate to a high temperature. This substrate we have to heat, and this substrate we have to heat to the high temperature. Is it clear? After heating the high substrates to high temperature, what should we have to do, guys? We have to expose. What type of impurities here required, since it is a N well? Absolutely, you required which type of diffusion here? You required a p diffusions here, right? Is it clear? You required p diffusions here. Okay, here you required which type diffusions? N diffusion. Absolutely, you required N diffusions. I hope that are you clear. But anybody, will you please tell me, when you are exposing p type impurity gas here, here also the p-type impurity gas will be exposed. Okay, then what will happen? Here the p-type will form, here also the p-type will form. Therefore don't forget, you have to mask when you are diffusing p-type. Okay, at this position you have to mask. When you are diffusing n-type, at this position you have to mask. I hope that are you clear. This is an important point, don't forget this. Is it clear? Now after diffusion, what is the next step? Anybody from the class? Absolutely, creating a contact cuts. We have to create a contact cuts like this. Once again, we have to grow thick oxide here and here. Okay, and here also there is a thick oxide. Okay, and here also there is a thick oxide, thick oxide, and a thick oxide. Is it clear, all of you? After that, what will be the next step? Anybody? Absolutely, what will be the next step? Metallization. Which metal you are going to use? Aluminium. Therefore there is a metal I'm considering. I'm directly going to draw. Remember, that is a very important point. You have to do photolithography and etching after growing an aluminum metal. I hope that are you clear. And these are my terminals. What is this? Gate, source, drain. Gate, source, drain. Now if you observe that there is a PMOS, that means p-type substrate. Sorry for that, there is a p-type substrate and two diffusions. Therefore you can tell it is what? NMOS. Here if you observe that there is a, okay, n-type substrate and two diffusions, you can call this one as PMOS. Now in CMOS we know very well, two gates are tied together and we can give common input, and two drains are tied together, we can take common output. This is given to VDD and this is given to VSS. Okay, I hope that are you clear, all of you. This is input, this is input, and this is what? Output. I hope that are you clear. This is regarding about N well. I hope that are you clear. Now very important point. Once again I'm telling that. Okay. See, in CMOS you require two transistors, NMOS and PMOS. P mass should be always at left side, N mass should be always at right side. Okay, when you are considering PMOS substrate, definitely the well should be N well, since in N well you have to fabricate PMOS, therefore it should be at left side. That means we can call it the top side. Okay, here this NMOS should be at right side, that means you can call it bottom side. Okay, you should not change this. Is it clear? When you are going to perform P well fabrication process, don't forget here the well is going to be present in this position, P well. Is it clear? The substrate is N, here it will be changed P plus and P plus, here you are going to change N plus and N plus. I hope that are clear. Shall we look once clearly? This is okay, this is N substrate I am considering. Okay, and a well I am considering here, P well here. Okay, I am considering a P well here. This is my P well. Are you clear? This is my P well. Okay, now if you observe that I'm going to draw the structure, just that's it. I'm going to draw the structure. Okay, now we required a thin oxide here. This is our thin oxide, this is our thin oxide, sorry for that. This is our thin oxide. Okay, we required what? We required polysilicon. We required a polysilicon. Okay, this is our polysilicon. Okay, after that we require diffusions here. Don't forget here, since this is a P well, you required N plus here. This is N plus and this is N plus, right? Okay, this is what? N plus and this is N plus. Okay, now you required here what? You required P plus and you required P plus. I hope that are you clear, and the remaining process is similar process. Is it clear? That means creating a contact cards here, creating a contact cards like this. Okay, creating a contact cards like this. Okay, here also creating a contact card like this. After that metallization, you should perform metal and sorry for that here. Okay, you should perform here metal and metal. There is a gate, drain, source, gate, source, and here you're having a drain. Okay, then gate is going to be tied, drain is going to be tied. This given to VSS, this given to VDD, this given to VDD. I hope that are you clear, all of you. This is regarding about well fabrication process. I hope that are you clear. If you are having any queries, you may please comment. Okay, thank you very much. Have a nice day.